Hi, my name is Wikus Barkhuizen. I'm a postdoctoral researcher at the Gel Lab at Birkbeck. As part of our series of talks to celebrate the 100th anniversary of Rosalind Franklin's birth, I want to talk to you about some of the research methods we use in psychology that makes use of genetic information. Bit of background, my research focus is on the association between tobacco smoking and mental health outcomes. So we know from past studies that if you have been diagnosed with serious mental health disorders like bipolar disorder, schizophrenia, or major depression, you're more likely to smoke cigarettes regularly. And conversely, if you're a daily cigarette smoker, you're at an increased risk of developing psychotic disorders. But we're not only interested in discrete mental health disorders, we also want to understand what leads to these disorders. And so we measure experiences that resemble psychotic disorder symptoms, like hallucinations or paranoia, in the general population. From past research, we know that these experiences are associated with smoking, but longitudinal studies that derive these associations have limitations. So for instance, when we have a big cohort study, typically we assess people on their psychotic experiences and smoking every year or two. And even if we try to test for an association, we still need to know whether or not this association can be explained by other factors like cannabis or alcohol use. We don't always measure these things at the same time. So it's very difficult to distinguish between cause and effect, even in longitudinal studies. So in an ideal world, what we will do instead is perform randomized controlled trials. The reasoning behind randomization is that if we assign people randomly to either an intervention group or control group, we don't expect those two groups to differ on things like how often they smoke cannabis, or their ethnicity, or stressful life events, or other things that can explain the association between smoking and mental health outcomes. And so if we intervene, we know that any changes in the two groups are likely due to that intervention. The interesting thing we know about genetics is that there's a process of randomization that's occurred during the conception of all of us. So we all have two versions of each gene. We call these different versions alleles. And whether you inherit one version of an allele from your parent or another version of the allele from your parent is random during the process of meiosis. So, like I was explaining, if we want to test for an association between something like smoking and mental health outcomes, these associations can be explained for by things like alcohol, cannabis use, sleep, or factors that we haven't measured and haven't controlled for. But if we randomize, then confounding becomes less of a concern. And the way we do this in Mendelian randomization is by using genetic variants that are strongly associated with something like smoking, and we then test if there's an association between these genetic variants and our mental health outcomes we're interested in. And we get these associations from large genome-wide association studies that have already assessed whether genetic variants are associated with specific traits. Like all statistical methods, Mendelian randomization makes some assumptions. So we need to make sure that if we use genetic variants instead of a measure of smoking, that genetic variant should be strongly associated with smoking. And in fact, we usually use several variants rather than just one to make sure that we have a balance of associations. We also need to know that while confounders aren't as much of an issue due to randomization, these genetic variants shouldn't be associated independently with the confounders, nor should they be associated with our outcome without going through this path of smoking affecting our outcomes. So just to give you an example of what this might look like in my own research, We've assessed whether smoking initiation liability affects mental health outcomes. We also did the reverse. We looked at whether or not these mental health outcomes could affect whether or not you're more likely to smoke. And feel free to pause here and look at some of these effects. But in summary, the evidence we found was that smoking seemed to play a causal role in liability to develop disorders like schizophrenia, depression, and bipolar disorder. We did not find strong evidence that the reverse is true. So in other words, that people are more likely to start smoking because of their liability to develop these disorders. And we found some evidence, although inconclusive evidence, that smoking may have a causal role during adolescence when it comes to developing psychotic experiences, and specifically cognitive experiences and negative experiences. So, in conclusion, smoking may be causally associated with psychiatric disorders, and these findings are consistent with longitudinal evidence. This gives us more confidence in these findings. We also know there's plausible biological explanations for why smoking could affect brain pathways that have also been linked to schizophrenia, bipolar disorder, and depression.